Okay, so let's look at the next animation, which is about rain. We talked a lot about winds and trade winds and converging trade winds. We mentioned the tropical convergence zones. We said the monsoon is special. Here you see in the summer months, boreal summer months, which is the northern hemisphere summer months. So we also looked at the ITCZ, the Intertropical Convergence Zone, which mostly stays in the north because of various dynamic details that we will not get into. It's too much mathematics, physics, this and that at this age. It's not so easy to explain in words, but let's just say one of the reasons is that there is so much land to the north, and then remember we always talked about energy moving from the low latitudes to the polar regions because there is surplus of energy in the low latitudes and there is a deficit of energy in the high latitudes. Why? Because we are on a sphere, so the way energy gets distributed from the sun and what it does to the thermal energy and the albedo. You can see all this ice and snow and the albedo. You have to be careful because here we also say the white colors when there is no rain. So this is precipitation in centimeters equivalent. So you take the water and you convert it into centimeters. Usually rain is a flow, right? We talked about storage and flow. So ocean is storing water, groundwater. We talked about lakes and soils have water and so on. And then there is flow. There is evaporation flowing out of the surfaces and the rain that is falling down. So whenever there is flow, you are usually looking at some amount per unit area, square meter, square kilometer, square foot, whatever, and per hour, per day, per month, per year, and so on. So you talk about how much it rains during the monsoon, and that will be a flow, right? So the energy is flowing from the low latitudes to high latitudes because there is less solar energy coming in than thermal energy going out at high latitudes. There is more solar energy coming in than thermal energy going out. So if you don't move the energy, we'll keep getting warmer and warmer and keep getting colder and colder here. So we know that that's not happening, so we need to move energy. And ocean also moves energy, atmosphere moves some energy. Why am I saying all this? Because that is in fact related to where the ITCZ, the Intertropical Convergence Zone, goes. We already talked about the land heating and the ocean heating, the heat capacity differences, and how when the sun comes to the north, the monsoon gets set up because there is land close to the ocean, equator in the deep tropics. There is also monsoon rain over here. There is some monsoon over here, and so on and so forth. Of course, the original monsoon, the most famous monsoon, is the Indian monsoon, which comes from the word mausam, as we mentioned. So let's now look at this. We already looked at how temperatures move north and south with the sun. Ocean temperatures, land temperatures. We saw how vegetation cover blooms and then stops blooming during fall and winter months. That also seems to move north and south with the sun, as we saw here, right? So this is what we had seen, and we had talked about the special places in the ocean where they are locked to the equator for a good reason, and so on and so forth. And you can see that the ITCZ also moves north and south with the sun, but some places it remains to the north. And in this place, overall, this is a very warm region. It is also known as a warm pool as opposed to a cold tongue. So there is cold temperatures here, as you remember from before. So we talked about the cold temperatures here during the summer months. You can see this. During the boreal summer months, you get cold temperatures. So you have cold temperatures means no rainfall, so you can see very little rain happens here. You can look at the scales. Wherever it's white, it's basically no rain, desert. So you see the desert bands here, and India gets only rain during the summer months. So you can see during the summer months here, there's an explosion of rainfall over India, monsoons, Western Ghats, and also over the ocean, because ocean remains warm. So this warm pool is not only on the West Pacific around New Guinea and the Great Barrier Reefs and Philippines and so on. It's also over Indonesia and into the Indian Ocean. So in fact, this is called the Indo-Pacific warm pool, which you can see here. So this is the warm water here that is stretching from the West Pacific here into the Indonesian seas, into the Indian Ocean. So you can see spring and summer months, there is a lot of warm water here. So this is called the Indo-Pacific warm pool, as opposed to the East Pacific cold tongue here. The Atlantic looks somewhat similar, so it will have cold temperatures here in the summer, you can see, and warm temperatures on this side like the West Pacific does. And there is warm temperatures here as well in the Gulf of Mexico. So in general, it's good to remember that warm temperatures means rising air, expansion, cooling clouds, and rain. So you have under the ITCZ also warm temperatures. And then remember, the warm temperatures are going north with the Gulf Stream here, the Kuroshio here, and we saw that the Hadley cell sinks over here, it's rising over here, it sinks over here in the regions of no rain, which change seasonally, of course, as the sun moves back and forth. And we said the Ferrel cell and the polar cell meet here, and they have rising air as well. So this is precipitation. So you can see that there is clearly precipitation in these regions as well, not just here. So here warm air is warm water is causing air to rise, whereas here winds are coming together and forcing the air to rise. The temperatures are not so warm here, right? If we go back to the temperatures are always cold here. They are warm here, where the ITCZ here is here, but over the colder temperatures also we are having precipitation, because it can have snow and ice and not just rain. So that happens because you are forcing the winds to come together and rise. So there are differences when warm temperatures cause the air to rise versus when winds come together and force the air to rise. But nonetheless, whenever air is rising, you cause rainfall. In fact, these are called storm tracks, because that is very strong in the winter months. If you follow closely the months here, you can see October, November, December, rain, 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 rain. So that's happening in the winter months. So they are called storm tracks, right? So you see where the deserts are, and you see how India is not a desert. So the deserts don't spread this way except during the fall winter months when we don't get rain. But if you look at average rain, the deserts go this way, Middle East, and then they go north and then into Mongolia and so on. And there is Namib Desert over here, and there are some very dry regions over in the west coast of South America. And of course there are some Chilean deserts as well. Australia has a lot of deserts, and the Southern Ocean again looks very different than the Northern Hemisphere here, right? If you look at all the pieces of the ocean that are creating some maritime weather versus continental weather, you can see that this is like a channel. So you have these bands of rain that stretch right across. So as we come into the Southern Hemisphere summer, you can see that there is some convergence zone here, there is some convergence zone here, and there are bands of precipitation here. And remember, there are strong winds here, the furious 40s and the screaming 60s and something other 50s that you can look up. Okay, so that is the precipitation story. Remember again that this is showing weekly rainfall every week of the year, and it's a climatology, which we explained before. What they have done is take all the rainfall data from satellites and so on from 1979 to 2000, and they have averaged each first week of January, each second week of January, each third week of January and so on for each week throughout the year, all the years are averaged to get the climatology of rainfall. Obviously, you can measure rain very easily on land using rain gauges or buckets and so on and so forth, but on the ocean, only on islands you can have some rain gauges. In the open ocean, obviously you will have to get data from somewhere, and it is the satellites that are sitting up in the sky and looking down and giving us estimates of rainfall. So it's very interesting how satellites can measure clouds and water vapor and carbon dioxide and rainfall and winds and so on and so forth. Okay, so leave this precipitation here, and then in the next podcast we'll come back and look at winds. And again, what you have to do is relate the winds, wind convergences, trade winds, westerly winds, where the convergences happen, where it rains, where the air sinks and it doesn't rain, so you get deserts and so on and so forth. So this is how we understand the Earth system. Energy, winds, temperatures, humidity, rainfall, vegetation, deserts, and then humans. Humans on top of everything. Okay, so see you in the next podcast with the winds, just as a recap. Okay.